Hello, my name is Kyle Barron. I'm a software engineer at Development Seed, and I'll be talking about GeoParquet today. First, a disclaimer that I'm kind of sick today, and so hopefully I don't I don't forget my slide or something like that. Uh, so I want to talk about GeoParquet, which is a new file format for geospatial vector data that has been gaining a lot of traction. Version 1.0 was released last summer in September 2023, so it's been over a year since GeoParquet 1.0 has been released. Version 1.1 became official in June of this year, and GeoParquet 1.1 adds a lot of new features like spatial partitioning and like native GeoArrow like geometries in GeoParquet. And so there's three real parts of GeoParquet that really excite me. The first is that it's cloud native and has potential to scale with the cloud. The second is that even when you're not using it in a cloud native fashion, GeoParquet files are really fast to read and write. And third, that it integrates really well with other new technologies, namely GeoArrow. And so the cloud native aspect of GeoParquet is that it's very easy for readers to read GeoParquet files that are hosted on the cloud without having to download the entire file first. And so that is due to the underlying structure of the Parquet file that GeoParquet is built on top of, where Parquet has internal chunking, which means that instead of storing all data for each column in a single contiguous region of the file, it stores all the data for the first, say, 100,000 rows in one big block, and then all the data for the next 100,000 rows in the next block, and so on. And so that means that you can read just part of the file without having to read all of the file in terms of the rows. Because GeoParquet is also a columnar format, you can read just a few of the columns instead of reading all of the columns. And so together, these make it easier to read portions of the file really efficiently. And all of this is contained in the metadata at the end of the file. And so any GeoParquet reader that is able to take advantage of these range requests will usually do this automatically for you. As I mentioned, GeoParquet 1.1 added support for spatial partitioning. And so I want to be clear of the difference between what I call spatial partitioning and spatial indexing, where other formats such as GeoPackage or flat GeoBuff have a spatial index as part of the file, which means that every single row is included in this index. That makes it really fast to get a small number of rows out of the file, whereas GeoParquet, being an analytical file format, only maintains the spatial information of each chunk of rows. This means that it can scale a lot better than some of these other formats at really large scales. The spatial partitioning in the way that we've defined it in GeoParquet allows you to choose how you sort the data. And so we don't say you have to sort it with a specific method. Somebody in the future can define a better method for their specific data, but still store the metadata in a way that's compliant with GeoParquet. You can use either single file or multi-file partitioning with GeoParquet. And so here in this image on the right, this says file 1.parquet, file 2.parquet, file 3.parquet, and so on. But those boxes could also represent different groups within a single file. And so there isn't too much difference whether it's multiple groups within a single file or each file is stored, each group of rows is stored in a separate file. There aren't too many engines yet to create partition data. I think that's something that the community is still working on, of having a good solution, especially a good open source solution. I think Sedona and Fused are a couple examples of creating some of this data, but I haven't actually created a large partition data set myself yet. But one data set that does exist is the Overture data set with a lot of different Overture is a data set that expands on OpenStreetMap and includes a lot of data in this GeoParquet format. And so Overture Maps has this Data Explorer website, and I'll actually switch to the Data Explorer live. And so when you're looking at the data on the screen, you see how it loads super quickly. That is actually not GeoParquet. This is PM tiles. And in the network tab, hopefully you should be able to see the network tab on the right side of the screen. You can yell at me if you can't see that. You can see all of these requests into the PM tiles file as you zoom around. But then this download visible actually loads from the GeoParquet files directly. There's part of this could be better and is something that should be deployed in another Overture Maps really soon, where right now, the first time you do this, when you load a page, it takes a little while because it has to load the metadata from all of the like 200 different files in the buildings data set. But then this, especially once we improve the performance of loading the metadata, this took maybe 10 seconds to download this viewport directly from the GeoParquet files in the cloud. Using WebAssembly, it brings that GeoParquet into the browser, and then with the current implementation, just saves that as a GeoJSON file that then you can load in a separate environment. Beyond the Overture Maps Explorer, in JavaScript, I also wanted to give a demo of reading spatially partitioned GeoParquet. Let's restart this kernel. This is a notebook example that you should be able to find as well in the GeoArrow Rust library. I can put a link to it later, but there's this examples file. I'll put this in the chat. But this uses the beta version of a library I developed for working with GeoParquet files. That's a Python API, but uses Rust under the hood. And so this loads data manifest from Overture, constructs these files. There's actually 200 of these files, to these GeoParquet files. And then we can construct this Parquet dataset object where when I run this cell, it makes a request to all of those different data sets or all of those different GeoParquet files, gets the metadata of all of them. And then we can get information like the number of rows in the data set, the number of row groups. So here we can see this is like 2.4 billion rows, I believe. And then this should, hopefully the internet is okay while I'm presenting, but I'm able to pass a bounding box that has to be in the same coordinate system as the data. So this took 9 seconds now to fetch a table of this data based on this spatial bounding box into Python. So that manages which files in the background need to actually be read directly from the cloud into Python. And then this is an example with a Python library I developed called Lawnboard that is now able to render all of that data that we just fetched from the Overture dataset directly. And then I just have a couple more minutes, but I'll say that beyond being cloud native, it's really fast to read and write, and it's often smaller as well. So these are some benchmarks that I made a little while ago that showed that GeoParquet, especially with this ZSTD compression, was much smaller than other file formats while also having usually faster read and write time. Even when you're not using the cloud native aspect, it's really fast. So here, this is an example of it takes 800 milliseconds to load this 3 million point GeoParquet file from disk, and then another 800 milliseconds to render that in the browser. And so I'm using this in my library called Lawnboard for big geospatial visualization to send the Parquet data from Python into the browser because it makes it faster to both write and read the data. It also has a really symbiotic relationship with this other uh, specification called GeoArrow that makes it really easy to use spatial vector data performantly in memory. The big difference here is that GeoParquet is a disk file format, whereas GeoArrow is a memory format. And so you load a GeoParquet file into GeoArrow. When you see this table object, this NYC buildings, this is the repr doesn't look very pretty at this point because it has lots of nested columns in this Overture buildings data set. But this is an arrow table that then you could really quickly pass zero copy to polars or DuckDB or pandas or PyArrow. So there's a lot of really good interoperability here that GeoArrow enables. GeoArrow is making it faster to work with other libraries, including GDAL. And so now GDAL has faster support with GeoParquet because of using this GDAL interface. And so it makes both GeoParquet and other data formats faster to work with between GDAL and bindings such as Python or R. And so in conclusion, I think these three aspects of being really cloud native, hopefully these demos piqued your excitement a little bit of we can have really efficient spatial filtering directly from the cloud. And then I got distracted with the questions coming in on the chat. So yeah, I have a couple minutes, so I'll take a couple questions. How can you make sure the spatial partitioning is enabled in a large file? I think this is a difficult question because I think most or spatial partitioning is only really useful on really large files. I think it's good to have on most files, but a data set like Overture buildings couldn't even be usable without this spatial partitioning. I don't know if which software even creates this by default. I don't think GDAL does yet, but I think hopefully there'll be more implementations soon in the future. GeoParquet is so the next question was, is there something similar to COG in GeoParquet, specifically generalized versions of the same data set in GeoParquet? I think GeoParquet is really focused on being an analytical data set. And so it doesn't automatically make these overviews that are really intended for a visual usage. I think for that, you probably want to look more at PM tiles with its or use GeoParquet in conjunction with PM tiles, where you have PM tiles providing the overviews to make it really easy to visualize some of this data, while then you can use GeoParquet directly for analysis, for compute, or for visualization when you want to see the full data. And yeah, I think as Michael noted, there is new GDAL support for faster reading from GeoParquet, but I don't know if it does writing spatial partitioning. And then I guess I can do one last question. How do you efficiently transfer large GeoParquet files over the web? Streaming per se doesn't work with GeoParquet because it's in the footer, but you can still provide this like fake stream where it's essentially an async iterable of batches. And so it's actually still okay if the data is in the footer because you can first load the data from the footer and then go back and load further data from inside the file. And so it kind of looks like a stream, even if it's not a stream. But even beyond that, using using these range requests is faster. And yeah, so GDAL will write the covering bounding box, but just writing the covering bounding box isn't actually enough. You want to sort your data so that the column that contains that covering bounding box is actually useful, because if you have a random ordering of all your data, then you will have some some bounding box information, but that bounding box information will be meaningless because all of the data oversects everything. Oh, so maybe that's actually how to sort by BUX. Well, I don't use GDAL to write my GeoParquet, clearly.